In today's class, we will discuss about various operations which are performed on process. In the last classes, we have seen uh, some details or some information about a process, how a process is created, and how um, it is managed in the computer system. And we have seen other topics which are related to the process also. So in today's class, we will see what are the various operations which are performed on process. So let's start our class. The first, wait a minute. Okay, sorry. So let's see the various operations which are performed on a process. Okay, you can see the list of operations in the slide. The first one is process creation. The second one is a process preemption. The third one is process blocking, and the final one is the process termination. So there are many operations which are performed on process, like starting from the process creation to the termination of a process. But here I'm listing some of the important operations which are performed on a process. So the creation and the termination are the two basic things a process have, and we will see what is process preemption and process blocking in detail. A process need to be created in the system for different operations. This can be done by the following events. So you know that a process is a program which is currently in execution. So the program which is currently in the main memory, we call that as a process. So in order to create this process, we have to perform some steps, or we have to invoke some steps in order to create a process. So you can see the steps listed here. First, user request for the process creation, or user instructs the computer to create a process, and the system will accept that request, and it will initiate the process creation work. And the third step is execution of process creation system call by running a process. So after the system initiates the process creation step, then the process is created using a function called fork, fork, fork. So fork is a normal function which is used to create a process. So I will explain that more about fork in coming slides. And after a process is created, a job is allocated or initialized to that process. So these are the four steps or the four events which happens when a process is created, or which happens in the process of creating this process. All right, so first, user request for the process creation. Second, the system accepts that request and initiates the process creation. And using the function called fork, the process is created. And after the process is created, a job is allocated to that process. Right. So here, you can, I will simply read out this thing here, and I will explain the content. A process may be created by another process using fork. Fork is a function here. The creating process is called the parent process, and the created process is called the child process. A child process can have only one parent, but a parent process may have many children. Both the parent and child processes have the same memory image, open files, and environment strings. However, they have distinct address space. So we can create process in two ways. One is creating a new process altogether. Okay, and second is creating a child process from the parent process. So when you create a new process, then that may be a new process, and that process is called as a parent process. And when you create a um, process for a already existing process, and that process is called as a sub process or subtask or a child process of the already created one. So first you are creating the parent process, and depending on the user requirement, you are creating the sub processes. So let me give you one example. Suppose you are playing a game, any game. So that game, let us imagine that that game is the parent process, and in that game, what you will do is you will um, use some controls, or suppose if you are playing a car race or a bike race, so you will use some controls to move that vehicle from left to right and right to left. Understand? So when you are moving your control to left, or when you want your vehicle to go left, you are performing some operation like moving your control remote, that video game jack to move to the left. So that means you are instructing the computer to create a sub process for the main process game. So moving left is, we can consider it as a sub process. So that process is created, and that process is called the child process of the main process called game. So in this way, for each and every task, a sub process is created. Suppose if you're working on a word document, and you are working and on it, and in between you are saving the document. So when you are instructing the computer to save that document, that means you are creating a sub process. The main process is your word document. Suppose if you are working on a resume, so the main process is the resume, and when you click on save button, or when you check the spelling of a particular word, or doing some subtask in this main process, that means you are creating, or you are initiating the creation of a sub process. So at the background, the main process will run. In between, depending on the user requirement, new sub process will be generated or created. So this is how it is done. So you can create n number of sub process, or n number of child processes for a parent process. So this is what happen when you create, when you are working on a word document, and this is how a process is created. So the function in major Unix operating system, or the operating systems which are close to this operating system Unix, most of them use the function fork, fork, to create a new function, or to create a new, sorry, process. So this diagram will explain the process of creation of a process. So using the fork function, we can create a parent process or a child process. Understand? Either you can by using the fork function, you can create a parent process or a child process. So when the child process is created, it has to be executed, or it has to invoke this execute function, which allocates some work to the child process. So when the child process is created, either it can share the work of the work which the parent process is doing right now. It can share the work of the parent, or a new work can be allocated to the child process. So this execute or exec function is used to um, write a program, or allocate a program code to the child process, nothing but allocating some work to the child process. So after that, after the child after a child is allocated with some work, the child executes that one, and it terminates. After terminating that work, or the after child process terminates, Okay, then the parent process will will take over the control and it will resume the execution. So here two things can happen. When the child process is working concurrently, the parent process can also work. Okay, or the parent process will wait for the child process to get terminated or to complete its execution, and after the child process completes its execution, then the parent process resumes its work. Suppose if you are working on a word document, man. Okay, so I will give you two examples. If suppose if you are working on a word document, um, and you are trying to save the file. Now, in that case, the parent process will be in wait mode. That means you are not typing anything, you are not doing any work, and you are saving the file. So, saving the file is a sub process. So, the parent process will wait until the file is saved, or until this child process called saving a file is executed. And when we save the file, then afterwards this child process will terminate, and the parent process, that is document which is running, will resume its execution. So this is one case. And the second example is the parent process will run concurrently with the child process. So the second example is the game you are playing. So the background of the process is the game. Suppose you are driving a car, so movement of that car is still there. So in between you are moving your car to the left and right. So moving to the car to the left is a sub child or sub process created by the parent car. Understand? So while you are performing this left and right movement of the car, still the parent is running, right? So the car is still moving. So here the parent is running and the child process is also running. So these two are concurrently running at the same time. So this is the second type of execution. The first type is the parents waits for the child process to complete its execution. Okay, and the second is the parent and the child two simultaneously work on the same process or same work. Understood? Okay, so these are the two functions which play key role in creating the child process. The fork function will create a child process, and the execute function will allocate some work to the child process. Okay, so system called used for fork, used after a fork to replace the process memory with a new program. So the memory here, the memory of the child is allocated with some new program code or new work here. So for that we use exec function. Okay, when a process creates a new process, two possibilities for execution exist. The parent continues to execute concurrently with its children. The parent waits until some or all of its children have terminated. So just now I have explained these two scenarios. Okay, the parent and the child continues executing concurrently, or the parent waits for the children to complete their execution. So these are the two scenarios which happens when a child process is created. And the second operation which is performed on the process is process preemption. Okay, uh, an interrupt mechanism is used to preemption that suspends the process executing currently, and the next process to execute is determined by the short-term scheduler. Preemption makes sure that all processes get some CPU time for execution. So preemption is nothing but interrupting the currently executing process. Suppose one process is currently in running state, and this preemption operation will terminate or will stop that process which is in running state for a while, and it will allocate the CPU to the another process. So we call this operation as preemption operation. Okay, why it is done? Because in order to give equal chance to all the process which are waiting in ready queue, this preemption operation is done. So this preemption operation can be invoked automatically or based on some time sharing, or the preemption operation can be done by the some other interrupts also. So basically, interrupting some currently running operation process to give chance to the another process is called as preemption operation. So you can see that in this diagram. So a process in ready state is allocated is shifted to the running state, and which is in running state is preempted. Preempted means it is simply moved from the running state to the ready state, so that the another process in ready state can be dispatched to the running ready state can be dispatched to the running state. So giving equal opportunity to all the processes in the ready state, this is called preemption operation. Okay. And the third operation is process blocking. So preemption and blocking two are interrupts, but there is difference. See, the process is blocked if it is waiting for some event to occur. This event may be IO or input output, as the IO events are executed in the main memory and don't require the processor. After the event is complete, the process again goes to the ready state. So you can see two examples here, scenarios here. One is preemption operation and the blocking operation. The preemption operation will is done automatically or in some way or the other, but the block operation is done when an IO interrupt is occurred, input output. So suppose um, events like giving instruction to the printer or monitor or anything else, any IO input output operations. uh, so what will happen is that there is the process currently in the running state, when it encounters the IO interrupt, then it is sent or it is blocked from executing, or it is blocked from currently running, right? So it is sent to the blocked queue, or we can say it as a device queue, like we discussed in the previous class when we are discussing about different types of queues. So that process is sent to the device queue or the blocked one, and after the IO operation is completed, that process is again shifted to the ready state. So simple, if the process is running and some IO operation has occurred or IO interrupt has occurred, then that process which is currently running is blocked and is sent to the device queue or the blocked queue. And after the IO operation is completed, it is again shifted to the ready queue. Okay. So in the both cases, there is a stoppage of the currently running process. The process which is running currently is stopped. Okay, in both the cases, right? And the last one is the process termination. This is the final state of the process life cycle. So after the process has completed the execution of its last instruction, it is terminated. So when the work which is allocated to the process is finished, so automatically that process is terminated, or it's is deleted. The resources held by a process are released after it is terminated. So when the process is created, the child process will share some resources of the parent process, which is right now held by the parent process, or it can take resources from the operating system. And when that child process is terminated, all the resources are released, so that that resources can be used by the another processes. A child process can be terminated by its parent process if its task is no longer relevant. Okay, the termination can happen in many ways. The one way is the parent process terminates the child process. So when the parent process um, understands that the child process has finished its work and it is no longer relevant or no longer required, then the parent will terminate the child process. This is one way of termination. The child process sends its status information to the parent process before it terminates. So before the child process is terminated, all the information it has is shared, or it is simply transferred to the parent process. Also, when a parent process is terminated, its child process are terminated, as well as the child process cannot run if the parent process are terminated. So one way of terminating the child process is the parent process invoking the termination, and the second way is when the parent process is terminated, all the child processes which are associated with the parent process will automatically terminate, because they are linked with the parent. So when there is no parent process, then there are no child process. Okay, so this is how a process is terminated. So termination is nothing but closing a file or closing an application. Suppose you have finished your document, working with document, or finished playing a game. What you will do, you will close that game, right? So automatically when you close that game, the process which are associated with that game all are terminated. The parent process and the child process are terminated. Understood? So these are the different operations which are performed on a process. I hope you understood. If you have any doubts, you can ask me now.